In this video, we're going to be doing a sort of calculator demo. Now, R is an interpreted language, which means that each line of text the interpreter receives, it reads it, evaluates it, prints any output back to the console, and then loops back around waiting for the next input. And it's because of this that R can really be used similar to the way one uses a calculator, and so we're going to start with exactly that. So R does support the standard set of arithmetic operators through addition, subtraction, multiplication, and division. And if we click the link here, you'll see we get a listing of the operators along with their precedence, or the order in which they'll be evaluated. Now, this list contains more operators than we're actually going to cover in this notebook, but we see here we have the plus and minus unary operators. Here are the binary arithmetic operators for multiplication, division, addition, and subtraction. We also have comparison operators for less than and greater than, as well as Boolean operators for not, and or. And then finally, at the end, we have our assignment operators. Now, the operators are evaluated from top to bottom in this list. So those at the top are evaluated first, and those towards the bottom will be evaluated last. So if we return to the notebook, let's say we enter an expression like 2 plus 9. The interpreter is going to read this line, it's going to evaluate it, and then it's going to print 11 here, as we see, and then it'll loop back for more input. Now, we don't necessarily see this in Jupyter Notebook because we sort of work in these discrete code blocks, but in the interpreter, say at the command line, after evaluating and printing the result, the interpreter would then loop back and you'd see another prompt waiting for input. Now, if we type, say, another expression like 4 multiplied by 6 minus 2, the operators in this expression will be evaluated according to their precedence. As we saw in the previous listing, multiplication is listed higher than subtraction, so the 4 times 6 will be evaluated first, and then of course we'll subtract 2 after that, giving us a result 22. And if we wanted the subtraction to occur before the multiplication, we can of course use parentheses. So I can write 4 multiplied by 6 minus 2 in parentheses, and now the subtraction occurs first, giving us the result 16 instead of 22. So as we've seen so far, operators at different precedent levels are handled according to where they rank in the listing that we saw on the previous webpage. Now, for those operators at the same precedence level, they're typically evaluated from left to right. And so if I write 1 minus 1, I'll of course get 0. And then if I subtract 1 again, I'll get minus 1 because the operations are handled from left to right. Now, if I were to take a different operator, say the exponent operator, and I say 2 raised to the second power, I of course get 4. But if I then raise that to the third power, I don't get 64. Instead, I get 256. That's because this operator is actually evaluated from right to left. And so we have 2 raised to the 8th power instead of 4 raised to the third power. In R, division is by default floating point. So even if I were to take the integer 17 and divide it by the integer 3, I would still get a floating point result of 5.6 repeating, as we see here. Now, if I did want the integer result, that is integer division, I would have to use a different operator. And so you see if I type 17% slash %3, where this operator represents integer division and not floating point division, I will now get the integer output 5 and not 5.6 repeating, as we did previously. R also supports complex values through the I suffix. So I can type 16 plus 4i to represent a complex value, and then use these values in operations similarly to how I would use real values. Also, R supports a number of built-in functions like logarithms and trigonomic functions. So, for example, I can say square root of 100, and you see we get the answer 10. Since R is meant to be a language for statistical analysis or data analysis, many of these functions come right out of the box, whereas in languages like Python, you'd have to import a math library or something similar. From this point of view, R is actually quite convenient to use.